Hello. How are you doing? I hope your day is going well. We are going to get started here for live lesson number 7. This is week 4, and we are focusing today and this week on understanding the law of conservation of energy and understanding the types of energy that we will regularly come across in the real world. And I start to identify some of the energy transformations that occur as you change matter. So, some reminders. First of all, please make sure you're checking assignments from previous weeks for comments, for questions, and for your grades. I have returned a lot of things to people for them to tweak or to make better or to turn in the first time. Please make sure that you're on top of that. Next, remember that if you are in a live lesson, all you need to do is mark as done on Google Classroom. However, if you are here watching this video because you were not in the live lesson, then you need to watch this entire thing. Along the same lines, I'm having some issues with folks not watching the entire video, which means that your grade is not fully recorded on Edpuzzle, nor can it then be uploaded to Google Classroom. So please make sure that you watch to the very, very end. I usually try to put some sort of question at the end that forces you to get all the way there, but don't hop off early because otherwise I don't get your score. It's just marked as a 0. Remember our special announcements about 2 mutes and a boot in the live lesson, as well as appropriate ways to use team chats. And remember to not only show yourself some self-love and appreciation, show others self-love and appreciation. I am showing lots of appreciation for your effort thus far. Thank you guys for kicking some butt. Next, I want to spend a second to see if you can log into Clever. And this might be something as I explore and we test this out together. This might be something that I ask us to do daily. So use the link, please, to log into Clever now using your JCPS email and Google link. So what this application does is it kind of is a one-stop shop for everything that you might need during NTI. It's useful for me because it allows me to see what exactly you're doing and spending your time on. So we're testing this out right now, but this might be a daily requirement in the future. These week's assignments, there are more than there have been in previous weeks, but each of them are fun, interactive, and shouldn't take a ton of time. So you should have already done the week 4 preview before this, which was number 15, the Edpuzzle video. You are watching the live lesson 7 video right now, which will give you information on how to do your next 2 assignments, number 16 and number 17, which I will explain at the end of the lesson. So if we recall, last week we first started talking about our first phenomena for this class, but really it's the first phenomena. And we are approaching this central question of where does all the energy and matter in the universe come from? And we first started exploring that by trying to understand what this guy, this weird 70s looking guy from that's really smart, what is he saying when he says, we are star stuff, or we are the children of stars? So some of us picked up on this when we watched the video last week. Some of us were so hyper focused on the weird clothes he was wearing, his funny accent, the fact that he was like in the grass by some cows. But here was some things that he said that should clue us into what he means by we are star stuff, or the children of stars. He said, our ancestors worshiped the sun and they were not foolish. It makes sense to revere the sun and the stars, for we are their children. There's that first one. He then said, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies, we are made in the interiors of collapsing stars. We are made of star stuff. So what he's implying is that stars make matter, make atoms, make these particles that make up us, which means that if stars make that and we are made up of that stuff, then we are coming from these stars. We are star stuff. We are the children of stars. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. Okay. By the end of this unit, this is all going to hopefully make sense, and you'll be able to understand that we are directly connected to what is going on out in our universe. So today we are focusing on this idea of energy and where this energy comes from and how does it change throughout a series of reactions. So let's start by brainstorming a list of at least 3, but do as many as you can, types of energy. So great, thank you guys. The list we came up with included things like kinetic and potential energy, thermal or heat energy, radiant energy or light energy, sound energy. You talked about nuclear energy. You talked about gravitational energy. You talked about and listed things like electrical energy or geothermal energy, right? There are so many different types of energy. And we're going to be exploring some of those today. So what we're going to start with is watching the majority of this video. This is a lab that we would do in class if we were all together. So it's kind of a bummer. And while you watch this video, I want you to think of 2 things. Okay, your 2 questions are up there on the left and they're going to stay there so you can remind yourself. But I want you to think about what types of energy are we seeing here? And how is that energy being changed? All right. Also try to think about where is the energy that's allowing this to burn coming from. So what we see here is a apparatus with a paper clip that has a Cheeto stuck into it, and the Cheeto has clearly been lit on fire. Above it is a free floating can. Inside that can, we can't see it, is a thermometer, as well as some water to measure the change in temperature that occurs as this Cheeto burns and releases a form of energy. We notice that the free floating can is actually even moving a little bit. So that might represent a form of energy there, as well as this very obvious energy down here from the burning Cheeto.
That's so cool though. Oh, it's dripping.
So as it finishes up burning, we're thinking about what are the types of energy we're seeing here, as well as how did the energy change or transfer? Or where did the energy have to come from for that to happen? All right, let's answer question 1 and now question 2. So what we saw there was the burning of a Cheeto. And in the burning of the Cheeto, we saw the release of a couple forms of energy, mainly light energy. That's why it was so bright when something burns. And secondly, heat. The heat went into the can, it went into the air. It even heated up the can so much and warmed up those particles of water in the water enough that the can shook a little bit, remembering that heat is a form of kinetic energy, energy of movement. Okay, but we got to think is where did that energy even come from? Okay, you can't just burn something and expect this energy to be there. There has to be energy somewhere before that. So where the energy came from before was the chemical energy that was stored in the bonds of that Cheeto. That Cheeto is a type of food. All food has chemical energy in it. And all it took was the burning process to change that chemical energy into thermal and radiant energy. And this represents what we call the law of conservation of mass. Okay, that thermal and light energy did not just come from nowhere. It had to come from somewhere before it. And where it came from, like I said, was that chemical energy. The law of conservation of energy states that energy cannot be created or destroyed, but it will change the form it's in. The total energy in the system will, however, stay the same from the beginning to the end. So that means however much of chemical energy there was in the Cheeto at the beginning, there needs to be that much energy in different forms at the end of the reaction. So if we were to be able to measure the amount of heat that was lost into the air, the amount of heat that went into the can, and the amount of radiant light energy that we saw, that should equal the amount of chemical energy that the Cheeto started with in the beginning. Right? So it's this idea that there is the chemical energy that is burned and released, our heat and our light energy. Now, anyone or all of you all hypothesize, where did the Cheeto get its energy then? Where did that chemical energy come from before it? Because it had to come from somewhere. Right, the sun. The ingredients in a Cheeto are mainly made of plants, things like wheat or flour or corn. And those things are all plants. Where do plants get their energy from? They get them from the sun. The sunlight, through photosynthesis, allows that radiant energy to be transformed into chemical energy stored in the bonds of the plant. That plant was processed and made into a Cheeto where those chemical bonds were still stored and then were released when you burned it as heat and light energy. So we are going to be exploring these different types of energies and these different transformations of energies through these two assignments. Number 16, which is a Kahoot that you are going to be playing, and then number 17, which is a simulation that you are going to be completing. So the Kahoot is a link that is posted on Google Classroom. It will take you to a space where you will be playing this Kahoot. You need to use your last name, comma, first name, or last name, comma, first initial. Okay, please do not put any nicknames or names that I will not recognize you for, because then I can't give you your grade for your work. Okay, this is a formative assessment. This is a means for me to see what you know about this. So if you miss a question, don't freak out, but I do want you to give your honest and best effort, right? You'll be playing by yourself, so it is a little weird, but at the end, there is a leaderboard of everyone's scores. I want someone to beat me, okay? Your next task is this Colorado PhET simulation. It is an assignment that is posted on Google Classroom. All right. So the process is going to be opening two links, which I will show you momentarily, opening the link to the simulation and opening the worksheet document that you're going to be filling out. Once you get those two things open, you are going to click on Systems. You are then going to make sure that when it goes to the system page, you have checked this box here at the top so that the energy symbols show. Then you're going to look at your instructions on the worksheet, in which it'll tell you the specific things that you need to have clicked and set. So for the first example that I do for you, you have the water faucet, you have the wheel, and then you have the boiling water over here. You then, step 4 is you turn on and start this process. And what you'll notice, because you have clicked the energy symbols, is that these symbols are shown as it moves through these three systems. What you need to do is identify what types of energy are at each of the three systems. So to start, we have the gray E, which is mechanical. As the water comes down, it spins within this wheel, and that spinning creates blue electrical energy. That electrical energy goes to the water and heats it up, because it is too a form of kinetic energy. Heating up that water then creates heat or thermal energy inside the water, causing the temperature to rise and some of the energy to even escape out the top. What you'll then do once you've identified those three is you'll write them on the three lines there. So to just again give you an idea of what this looks like, the assignment will take you here where you will choose Systems. You will click the energy box. You'll set it up based on what it tells you to for the 5 questions listed over on your worksheet. You will then make sure that it starts. So for example, with this one, you need to make sure that the water is flowing. If you have to do the bike, you need to make sure you got to get her moving as fast as you want. All right, with the sun, you want to check out if you have clouds or not. And with this, you need to make sure that it is heating up. Okay? Again, you're recording what type of energy you see at each step of these different processes. All right, so you have these 2 assignments to complete now that you have watched this lesson. To finish out and get you on your way to get working on those 2 assignments, please tell me where you're at today on your stress check. I'll be real honest, I was way down here because the technology during my live lesson did not do what it was supposed to. feeling a little bit better now, and I hope that you are in a better space as well. All right, good luck on those tasks. I will see you hopefully for your next live lesson, which will be on Thursday or Friday, which is lesson number 8, where we will talk about changes to matter and energy. See y'all later. Thank you for your efforts.